Morning, guys. Today we're going to take a look at pages 13 and 14 of the Unit 5 Classwork packet, and we're going to look at a few more examples of two-column fill-in proofs, this time involving side, angle, side. So we're going to start off with page 13, example number 4. All right. Let me just draw the diagram here for a moment. Like it was like this weird rectangle thing, right? That's been kind of like split into two triangles. Right. Alrighty. And alright, guys. So again, first thing we want to do, make sure that we account for our givens. How many givens do you guys see? Well, in the problem, they give us 2 givens. So those givens are already written down right here on the left. I'm not going to waste my time or my limited markers rewriting them. But as my reasons, I can just say that they are given to me. All right. Make sure as well that you put the information they gave you in the diagram. For example, they told you that JM and NL were the same, so I'm going to put a tick mark. And they also told you that JMN, so where's JMN? This one right here, itty bitty, is the same as LNM, which is right over here. All right. Okay, now notice what they did in step 3. They said, well, something is the same as itself. This thing in the middle is the same as itself. What does that mean? That means that we use the reflexive property of congruence, the reflexive property. And now, look at all the information I have in my diagram. Side, angle, side, side, angle, side. So thus, my final statement, which they already gave me, is my proof statement. So the two triangles are congruent. And the way that I know is SAS. Guys, I can't stress this enough. The more that you put the information as you go on through the proof in the diagram, the easier these proofs are going to be to fill in, and they're essentially going to fill themselves in, right? Like here, I can actually see visually side, angle, side. Now let's take a look at a slightly more I'm not even sure it's more complicated. It just uses an angle bisector. Let's take a look at one additional example on the following page, page 14. All right. And let's take a look at example number 5. Page 14, number 5. All right. So number 5 looks something like this. They gave me like this weird sideways triangle. Maybe it's isosceles, who knows? And they tell me ADC, ADC, B. Alrighty. Now, notice, just like in the previous problem, they told us a couple things, right? They gave us 2 pieces of information. So those first 2 pieces of information they gave me, of course, I'm going to make sure that I give my reason as given. For those of you guys who don't like cursive, that does in fact say given, even if I wrote it kind of messily. Sorry about that. And let's take a look next. Okay, so then they tell me this weird thing. Angle ABD is congruent to angle CBD. So they're saying, right? Well, before I do that, let me make sure I put the information I know in my diagram. Sorry, broke my own rule. Okay, so how do I now know this, guys? How do I now know that these 2 angles are the same? Well, take a look at the previous step. In the previous step, they told me that BD bisects angle ABC. That means that this thing right here splits the angle into 2 equal parts. So the reason that I'm able to say that those 2 angles are congruent is the definition of an angle bisector. Definition of an angle bisector. Then in the next step, they go one step further, and they actually tell me that something is the same as itself. They tell me that this segment right here in the middle, the shared one, BD, is the same as itself. What property was that again, guys? Well, that was none other than the reflexive property of congruence. And thus, my proof statement comes last. Take a look at what I have here. Side, followed by an angle, followed by a side. I could also have started with the purple and gone side, angle, side. So SAS. All right. Now, just looking for a moment at a few of the examples down below, okay? We're going to actually look at the evens together. All right, just very briefly, not necessarily even with the pictures, but just make sure you're looking with me. Example 2, would it be SSS or SAS? Well, notice the shared side. So I could put 3 tick marks on that shared side, and then I have SSS. For number 4, I actually have a problem. I have what looks like SSA or ASS. That's forbidden. That's not allowed, right? That's not one of the 5 that we learned. So for that one, you would just write a big frowny face and say, oops, sorry, no can do. All right. Now, number 6 is actually a little bit tricky, so I'm going to show this one drawn to the best of my ability, okay? Which means I'm probably going to have to erase something. Alrighty. So number 6 looks something like this. Meh. Okay. Now they tell me something interesting. Yes, they give me that I have some congruent sides, right? Yes, they do. However, the other thing that they tell me is that I have parallel lines. Why does that matter? That matters because parallel lines that are cut through by a transversal form multiple pairs of angles that are congruent. And in this case, these two, believe it or not, are actually alternate interior angles. If you don't believe me, just extend these lines and extend the transversal. And lo and behold, you've actually got alternate interior angles that are congruent. So for number 6, it would be SAS. Last but not least, for number 8, do you guys notice how angle ACB and angle DCE, they're like right across from each other, right? They're like vertical angles. So because they're vertical angles, what do you know about them? Vertical angles are congruent. So I could put those little tick marks, or I could put the arc symbol for those 2 angles, and thus by SAS, the 2 triangles would be congruent. All right. But guys, what it's all going to come back down to is 2 things. Number 1, putting all the information you can in the diagram using tick marks. And number 2, calling upon reflexive property, midpoint, angle bisector, vertical angles from previous units in order to show information within triangle diagrams.